Okay, so it's already a little bit after 11, 1 minute after 11, and I guess we can start if everyone agrees about this. Okay, so let me share some opening slides. Okay, so hello everybody, and welcome to the SPBP workshop. So this is the third edition of the workshop on security and privacy enhanced business process management. And I'm very happy that you are here in this workshop because first of all, this is a very big festival, I think, for every BPM community, because now we are having our BPM conference. It's a pity we are not able to meet each other having face-to-face meetings, but let's do the best what we can do. And also today is a very competitive day because we have a lot of workshops which are running in parallel together with SPBP workshop. So I'm really very happy to see you all here. Now, what this workshop is about, why we are here, what topics we are analyzing in this workshop. So the main objective of the workshop is to find the interplay, to find the alignment between the BPMN, the business process management, and different techniques, different technologies, which actually help us, the business process management, to do in the secure and private way. So there is the interplay between the BPMN and the security and privacy management. And actually, well, having this, we would like to understand, we would like to study what are the different techniques, including the privacy and privacy enhancing technologies, blockchain, smart contracts, distributed ledger, distributed process mining, artificial intelligence, which actually can contribute into the securing and well, managing it in a private way, the business processes. Also, the workshop includes the traditional aspects like the security and security risk management, including the compliance checking, privacy, security policies, monitoring, measuring, and everything what relates to the security and privacy within the BPM. And I'm very happy that now it's already the third edition. The workshop, although it's still remaining quite small, but the workshop is continuing with the interesting talks, and I hope that today we will also have the interesting agenda, interesting presentations, and also interesting discussions. First of all, I would like to give a very big thank you to everybody who has contributed to the organizing this workshop, to helping organizing this workshop. So it's really a very big thank you to all the program committee members who did review the papers, who contributed also with some discussion, and helped us to, me and Nicola helped to do this, this workshop. I'm also thank you to Mubashar, who did quite extensive publicity to the workshop. Despite the website, we also have the Facebook, Twitter, LinkedIn accounts where we were trying to advertise this workshop as broad as possible. And now let's see what we will have today. Today, we have the three presentations. So the presentation done by the Rashid Zaman, and the next presentation will be done as a video presentation. So Michael was presenting, but then Gert will participate in all the online discussions and questions, answers, and all the discussions. And also Actor Drew, he will present his paper. He will present also his paper. So basically, another important remark about the SPBP workshop is that we would like to make it as real as the workshop, as a little bit of the working conference, working workshop, where everyone tries to participate, and every discussion is very, very welcome. So basically, after the presentation, we will give the word to the discussants, the pre-assigned discussants who already read this paper and who will start the discussion with the author of the paper. And well, he will have like initial questions, what the paper, yeah. This is to start the discussion. And then everyone, of course, is welcome to join the discussion and to learn more or to give feedback to the authors. Okay, said this, I would like then to move directly to the first presenter. And the first presentation of the workshop is done by Rashid Zaman, right? And I will stop sharing my screen so that Rashid could start preparing. And the research is done together with the colleagues, with the Rashid's colleagues with Marwa Hassani and Bowajit Van Dongan, sorry for the names pronunciation. And the paper is about data minimization as a privacy and trust instrument in business processes. So yeah, Rashid, when you're ready, the floor is yours.
Thank you, Ramandas. So you people can see my screen now. Okay, thank you. So my name is Rashid Zaman, and I'm going to, the title of our paper is Data Minimization as Privacy and Trust Instrument in Business Processes. So in this presentation, I will very briefly talk about BPR per GDPR project, then about GDPR's delimitation of data. Then I'm going to talk about data perspective of business processes, and then our proposed approach, inter-process data degradation, which has basically two important ingredients: data degradation techniques and data degradation policies. Then I will talk a bit about our implementation, and then the challenges and future work for this approach. So first of all, a business process re-engineering for GDPR. It is basically an EU's Horizon 2020 project. The aim of the project is basically to devise a framework for enabling smooth end-to-end GDPR compliance of business processes. We are devising many different techniques for securing data in small and medium enterprises. And we are devising many techniques for that. So at the end, I will provide the website to look at different techniques. So now, about data. So we say that data is exploitable as an asset, as we know in BPM, that we process data for primary purposes of the organization. And then we have also secondary purposes, which adds value to the organization as well as customers. But there is a downside to data. So it can also be exploited by adversaries, so that there can be adversaries outside the organization which compromise basically the privacy through data breaches. And then there can be insiders who get illegitimate access to data and compromise the privacy of the customers. And and the downside is that then this aggravate the customers already have trust issues with the data processors, and then such situations like these breaches, they further aggravate the situation and also cause like financial losses to the organization. So the European Union introduced General Data Protection Regulation to delimit and contain the use and abuse of data. So it is trying to confront this problem from many fronts. For example, like it necessitates the consideration for privacy enhancing tools, and then there are different processing principles for the data controllers. For example, storage limitation, that you should store data for a certain period, not more than that. Then there is purpose limitation, like you should process data for only legitimate purposes. And then there is this important data minimization principle, which says that the data should be adequate, relevant, and limited to what is necessary for the processing, legitimate processing. So our work is basically related to this limited aspect of data minimization of GDPR. So data perspective of business process. So usually when we hear about GDPR or processing of data, we usually like hear about data from perspective of data repositories. But in this work, we are basically looking into data and GDPR from the perspective of business processes. So we know that from BPM that a business process has a purpose. Then there are activities which form a business process, and these activities have their own many purposes, which basically contribute to the process purpose. And these activities basically require data for the fulfillment of the activity's purpose. So if we talk formally, we represent business process as patinets, where we have places, transitions, relations between places and transitions. Then we have marking, which basically denote the state of the process. And then we have process variables through which basically we access the process data. So our technique is called intra-process data degradation. So what is the design basis of our technique is that basically the purpose of the process doesn't change, but we think that the individual purposes of the activities may be fulfilled with variable level of information in the data. So like some activities may require data at granular, higher information level, while others can be executed with less information level. So formally, we say that the information level of data, this is process variables, should be lowered at suitable points in the process timeline, such that like we can still complete the process, but we can degrade the data. We can basically lower the information level with the passage of the process. So there are now two important ingredients of this approach, like how can we degrade data and when shall we degrade data, so that we can still successfully complete the process. This is an example process of a car dealership. We will refer to this process example throughout the presentation. So I would briefly explain the process. So this is a car dealership process where there are people who opt for a test drive of a car dealership. And let's suppose we have multiple events of car test drives in an year. Then customer register for a test drive. Then there are certain checks. For example, we add the check of the customer who of the person who applied for a test drive. Then there are different other tests, financial or driving license change. Then once we are satisfied, all the checks are okay, then we assign that person to an event, and then at some point in the time we plan a drive. If the checks are not satisfied, then we can like regret the event. So our assumption is like initially when we are making the age check and other checks, we need data at a higher information level, but as we progress through the process, we need information at less detailed level. Data degradation techniques. So we identified two important things, like how can we degrade data. So basically what we assume that a process variable can have multiple distinct values. So all of these values can satisfy the purpose of the relevant activities in the process. But what we can do is that we can order these values in order of like decreasing information level, and then with the passage of the process we can like decrease the information level. We can assign the values to the variables with less information level. And how we can do that? Basically, we have two ways to realize this. We have vertical approaches and we have horizontal approaches. For example, if we look at dates or addresses, they form basically an hierarchy. So what we can do is that with passage of the process, we can like drop information from this hierarchy. For example, first we can drop the house number, then we can drop the street address and things like that. So what we are basically doing is that we are marching through to a hierarchy, and we are dropping information with the passage of time. And then there are horizontal approaches where what we do, we transform the data to some alternate representation, which is not a hierarchy, but we lose information, like we introduce ambiguity to the data. So this is how we can basically degrade data. We can reduce the information content in the data. The second important ingredient of our approach is like when to degrade data. So which is basically the suitable points aspect of our data degradation approach. So basically we devised three policies for our approach. One is time-driven data degradation, the other is event-driven data degradation, and the third is event-driven data degradation with margin. Regarding the time-driven data degradation policy, so what we do that we degrade data at predefined time instances, like we define the instances, the degradation instances a priori. For example, we say that let's suppose degrade data element date of birth one level every week. So we have predefined time instances, and we basically degrade data at those instances. So if we look at the diagram, policy diagram in the picture, we see that on the x-axis we have time instances, and on the right y-axis we have basically the information levels. So we can see that at T1 we say that we degrade the information to level 1, and then at T2 time T2 we degrade the information further to level 2. The problem with this approach is temporal deviations. For example, so we assume that the activities which require information at level 0, they are basically executed till time T1. But if there are temporal deviations, for example, activities were not executed till T1, then they would be starving for the data at a higher information level, which is not there anymore. Another downside of this policy is that for example, the activities were executed well before T1, then we are unnecessarily retaining information, which is although superfluous. Our second policy is event-driven data degradation. So here, basically, the degradation of data attributes is triggered by activities of the process. So, for example, if we look at the figure, after check edge, we don't require information at level 0 anymore. So what we do after the check edge activity is executed, we basically degrade the information to level 1, and then it is assigned to event activity. We don't require the information at level 1, and we basically degrade the data to level 2. So the downside of this, like what could be a potential threat to the approach, is basically the control for deviations. For example, if due to any reason, like we know the business processes are prone to deviations, assigned to event activity was executed before check edge, then we already downgrade the data to level 2, and then when check edge activity is to be executed, it requires information at level 1, which is not there anymore. So it can cause data starvation. This policy can result in data starvation. Our third policy is basically event-driven data degradation with margin policies. So we know there are classes of processes where you cannot delete data abruptly because due to some, for example, regulation or preemption is expected. For example, as we know, GDPR gives the right to customers that they can object to a automated decision. So, for example, you made an automated decision and activity, and then the customer has the right to object to this decision for, let's suppose, 14 days or 1 week period. Then you cannot delete the data abruptly after this decision activity, but you have to retain it for some time. Similarly, there are some other scenarios. For example, the management usually reviews the cases which are going towards a negative decision. So if we see that the case is going towards a negative decision, then we need to retain it so the management can like analyze the cases. So there are different situations where we cannot like delete data abruptly, but we have to keep it for some time. And if we look at the policy diagram, so we see that after the check edge, we don't need this data at information level 0, but we do not degrade it abruptly, but keep it for some offset time. And then after assign to event activity, we don't degrade the data from level 1 to level 2, but keep it for some time. And after some offset, we basically degrade the data. So these are basically our three data minimization, data degradation policies. Now the concept implementation so basically to illustrate the effectiveness and viability of our approach, we implemented the same example process in Camunda BPM, which is basically a process automation workflow automation engine. So we implemented the same process with event-driven data degradation policies. So now we can see that basically the customer provided data at register request activity, and then we can see that the date of birth is in with full data. And then once we execute the age check, we can see that we have degraded the data. We have dropped the day of the date of birth. And then once the all the three checks are performed, still the data is there. And then after executing the assign to event activity, we can see that we have degraded the data further with just year of the birth. So now to look at the effectiveness of our approach, assume that data breaches happens at different instances in this case. So if a data breach happens at this point, when we have degraded the data, we have dropped the date from the date of birth. So we are basically exposing less information than full date of birth. Now imagine that a data breach happens at this stage when we have degraded the data to like just to year of birth. Now we are even exposing less information to the adversaries. So this approach, what this approach do is basically decreasing the exposure aftermath. And now basically the challenges and future work. So the first challenge is basically the structural and behavioral diversity of business processes. So we know that business processes has loops, they have choices, they have different constructs. So our policies are good for sequential processes with a bit of parallelism, but when it comes to choices and loops, so then our policies may suffer problems in their cases. Similarly, we have the complexity of the processing environment. So, for example, we have multiple processes in the organization, and they are acting on the same data. They are either processing the data concurrently or sequentially or in a cascading style. So how to tackle this situation in data degradation? It's a challenging situation. How our policies are not able to face this situation. Similarly, another case is beyond boundary processing as part of single process. We know that at times there can be multiple organizations which are basically processing the same data. So our policies are not able to deal with this situation where there are multiple organizations and they are processing the same data. And then there is this business processes are prone to deviations. We know that business processes has different deviations, control flow deviations, temporal deviations. So so as we discussed in event-driven data degradation, that control flow deviations can impact can cause data starvation in business processes. Similarly, if we have temporal deviations, for example, like we were expecting a process to be to become some activities to complete at up to a certain time, but they were not completed up to that time, then we are probably going to face performance bottlenecks with respect to the data degradation. For example, we may have a bottleneck for a lot of data degradation activities. Thank you. This from my side. I think I was first.
Thank you very much. And now I would like to invite the discussant of this paper, Actor.
Yeah, so hello, and
Hello.
thank you for the nice presentation.
Thank you.
I have questions maybe that can be divided into more theoretical principle and then more application related practical. So a theoretical question in the paper you discuss on one hand you say the data degradation is like a linear chain where each next level contains less detailed, more coarse-grained information. But on the other hand, you also give already an example of, for example, how a date of birth can be degraded in several incomparable ways. For birthday celebration, you only need the date and months, and you don't need the year to know when somebody's, like if you want to congratulate a colleague, when you don't need to know the year, but for checking whether they are of legal age, or for example, you do need the year. So in this case, the possible degradation paths, they actually form a graph which is not linear. So how do you think this could be handled in real life? I can only see a way to just keep multiple parallel fields where each field has their own degradation policy, but this seems like quite a large overhead.
Thank you. Yes, you are right. So basically, we assume that the ordering, like the privacy reduced ordering, is different for different scenarios. For example, in one business process, we have we just degrade with dropping the date and then month. But there can be other scenarios when we drop the other way. So so you are right. Every business process has its own dynamics, and therefore the degradation is different for every process.
Mm-hmm. And also continuing on this topic of degrading dates, I noticed in your screenshots of the process models, you are using a string type to represent the value of the date where the detail level is different. So do you foresee that this will also be a significant problem in practice, where, for example, a typical RDBMS is unable to store a date value with only a year, and you would need some workarounds to overcome this limitation?
Yeah, you are. It's perfectly true. So basically, the workflow is implemented in Java, and Java has this problem that it cannot take dates as incomplete dates. So it automatically inserts like 1st of January if you give it an year as date. So that was basically an implementation problem in Java. That's why we use a string for that.
Mm-hmm. And I think this problem will be also present in a lot of other environments.
Exactly. So then what we do is like, so in the background in the repository, it's basically a date, but when we manipulate it, we cast it to string, and then we again, like when we are storing it, we can store it as date in the repository. So it's all about like processing it.
Mm-hmm. On another topic or thread, you also mentioned the difficulties with handling the degradation policies in business processes that may branch or loop. I think maybe it could be helpful to look at the process graph and derive some sort of state X or step X may follow step Y in some scenario. This kind of relationship on this graph, and then use this one to decide. So if it is a case that in some execution flow, step X may follow step Y in the process, and step X needs some data on a higher accuracy or higher information content level. This means that at step Y, it is not safe to delete those additional details. Do you maybe, this seems quite natural, so probably you have also already considered this approach. Do you already have some preliminary ideas?
Thank you. Yes. So actually, we have some prediction techniques. Like we can, based on data, we can predict like most probably this case will go in this direction. So for example, if we know based on some executed process, we know that now this case is most probably going to be enter the loop, then it's safe not to degrade data. But if our predictor says that no, it's most probably going to complete, it's not going to loop, then we can degrade data. So predictors are like, we have this type of predictors in process mining. So hopefully we will look into that aspect, like using predictors for like predicting the behavior of the process.
Mm-hmm. Yeah, interesting, good.
Thank you.
Maybe I should give other people also chance to have questions. Even I have a couple still, if nobody else wants to ask.
Okay, is there any questions from the audience? You can write your questions in chat, or you can also just, unmute yourself and tell. Okay, Actor, I think still floor can be yours.
Mm-hmm.
Anyone else, if wish to ask some question, please write them in the chat, or you can after that unmute and ask this question.
So the next topics that we might want to discuss at some level is this inherent tension between convenience and security, as it often happens in many cases. So on one hand, it is more secure to minimize the data that you retain about clients in your system. On the other hand, clients tend to get irritated when they have to re-enter the same data every time they come back to you. So I fully appreciate there is no clear-cut answer, do this or do that in general for these kinds of solutions or for these kinds of problems. But what is your feeling how this is going to evolve in the future?
So I think there are multiple type of customers. So there would be one class of customers who would be very happy with this approach, because they know that their data is not retained. For example, in Netherlands, when we apply for a train card, so we upload our picture, and then they explicitly ask us, do you want to retain this picture for future use? So if you want to issue another card in future, we can retain this picture for you, or if you don't want it, we can just delete your picture. So on one hand, basically, in my opinion, for some customers, it may basically increase the trust of the customer in the process. But then there may be other type of customers who get annoyed, like, I provided you this data, 1 week ago, and now you are asking me again for my date of birth, so they can be annoyed. So it, in my opinion, it's basically depends on like the type of customer, what type of customer you are dealing with. But majority of it's my personal opinion, majority of people would be like, it would increase their trust in the business, in the data processor.
Mm-hmm. You mentioned in your papers that you have actually implemented this. Do you also have some kind of estimation of how much overhead this data degradation process brings into this workflow execution engine, both in the process definition stage and then later in the actual execution stage, because the engine needs to keep track of all of those degradation requirements as well?
To be honest, not much, but it depends on the process. So we have type of process we call single instance process, and then we have multiple instance process. So a single instance process, for example, customer segmentation, when you have a lot of data and you are basically processing it in a single instance. So for those type of process, we expect a lot of overhead, and that's why we would like suggest basically the time-driven data degradation for such process, because there are less activities, but the data is a lot. So if you are doing degradation on a lot of data at the same time, then you are having a lot of overhead, data degradation overhead. But then there are other processes, for example, there are insurance applications or other things where you have a single process instance for a single customer. So then you have like, then you have a lot of process instances. In that case, data degradation overhead is very less because you have less information to degrade. In this case, then we recommend event-driven data degradation. So I don't know by heart the overhead, but it's not that much.
Mm-hmm. It seems we have another question in the chat. So yeah, I can.
Nicola, floor is
I can
yours.
stop now.
So Zaman, I've got one question. So my perception, but maybe I'm wrong, is that most of the data can be seen as binary from a GDPR perspective. What I mean is that either I need the complete data or I do not need it anymore. So from your point of view, how many percentage of that data, which kind of data are eligible for your approach, and are there some data that are in a sense not eligible to your approach?
Yeah, thank you. That's a very nice question. So basically, I cannot answer in terms of percentage, but if we look at like dates, addresses, genders, and some other fields, so they can be degraded. For example, in the slide there was an example, like at some point you require my complete gender information that I am a male, but then there can be other activities where you don't need my precise gender, but not female can suffice for that activity. So similarly, dates can be degraded, addresses can be degraded. So there are some data attributes which are degradable.
Okay, I also would like to ask a question.
Yes.
Actually, I have a few of them, and my first question is: okay, you are analyzing business processes. What are the constraints on, let's say, on your diagram? What needs to be in the diagram? Because at the moment I see only like activities connected with gateways, and okay, how you are able to capture the data from your diagram?
If I completely got your question, so one assumption is that basically the process should be like with requiring decreasing information level. So for example, in the initial activities in the process, they require information at a higher level, but then with the passage of the process, you require less information in the activities. If this is not the case, then we must say that this process is not data degradable. It's not fit for data degradation. Then either we modify the process or something like that. But then at least it doesn't satisfy for the complete data degradation.
Mm-hmm. But yeah, this is very interesting aspect actually. But my question was also about the actual design and implementation? Because you were showing in your prototype that you are analyzing this data, and this data is extracted from the business process model. You go decrementally with the data. My question is, how do you capture this data from the business process model? Are you capturing this data yourself, or how you indicate, or this is some automatic approach of doing this?
So basically, if I completely got your question, so we collect data from customers, and then this data is in the repository, and then we have process variables basically which map the data between the process model and the repository. So basically, we are manipulating the process variables for that.
I see. And I have one more question. Well, first of all, I think that the project itself is very ambitious. I know this is a European project, and I believe that different partners are working on the different compliance issues here. All right, my question is about the minimization or data degradation approach. Isn't it like conflicting with some other GDPR requirements in some sense? For example, there is article, I think 30, which speaks about the logging of the data. And basically when logging, you need to capture quite a lot of different data items, including that's quite a lot of them. And now what you're doing, you are kind of decreasing this number of, the amount of the data required. Isn't it like a conflicting requirements here?
So as far I remember, their logging is not for the data. It basically the logging of the activities, like what processing activities are basically you doing. So you don't need to store the data by heart. You need to store the processing, what basically what you were doing to the data, the storing the log of the activities.
Okay,
so,
I see.
Yeah.
Okay, any other questions from the audience? Actor?
I think we are pretty good already.
Okay, then. So thank you, Zaman, very much.
Thanks a lot.
Thank you.
Thank you.
Thank you. And then we move to the next presentation. So Michael Vendor and Gert Poels. And now I will share the screen and I will run the presentation done by Michael.
Hello, good afternoon, or at least afternoon here in Belgium. Today I would like to present to you our article, Decentralized Data Access with IPFS and Smart Contract Permission Management for Electronic Healthcare Records. So this is a work written by Michael Verdonk, which is me, and Geert Poels. So we both work at Ghent University, of where this research is also being performed. Now, currently, there are already electronic healthcare records problems, most of them interoperability between hospitals, and already several research efforts, such as MedShare, have tried to tackle these problems, the existing problems with electronic healthcare records, through blockchain technology. So since the technology of blockchain concerning immutability and traceability could help with several of the problems that they experience now with electronic healthcare systems, the belief is that this technology could change that. However, through the adoption of blockchain technology, we have already witnessed that different problems have also risen due to the adoption of the blockchain, or that several existing problems have still not been alleviated. Now, a first problem is that while, for example, permissions are managed through smart contracts, so if now somebody would like to have access to a patient's healthcare record, you explicitly need permission which is managed through the blockchain, in this case, smart contracts. The actual electronic healthcare record is still being stored in a centralized manner. Most of the time, this is done by the hospital providers themselves, so this is stored within hospital servers, or with data custodians, which could just be a third party that takes up the tasks to store the electronic healthcare records of patients. So we have a bit the ironic situation where you have a decentralized system to maintain the permissions of these healthcare records, but actually the data itself is still stored in a centralized manner. Now, this can resolve two certain problems. One is that healthcare providers still remain responsible for the maintenance and the security of patient data. This is not one of the core responsibilities of hospitals. It's also a very cumbersome and it's quite costly to maintain this data, which also often results in, for example, hacks related to these records. A second is that it's also quite easy to bypass the blockchain-based system, so the permissions are stored decentralized in a smart contract. However, since the data, the patients of the data is stored on centralized servers, you could just actually perform a search query where you can still access the data itself, sort of bypassing the blockchain-based system. Currently, no solution also exists how the system will handle, so the blockchain system, how it will handle the loss or the theft of a private key. So if public-private key governance is being used to maintain the permissions of patient records, how will you overcome the situation where, for example, a patient has lost his private key and therefore cannot no longer claim to be the rightful owner, at least digitally, of his or her healthcare record. And then we also have the question, who maintains the smart contract? So it's a decentralized system, but who will still perform, or who owns the smart contract and who can still update any of the mappings of the public-private keys? So this is also a question that remains with the current existing systems. So as a sort of process summary, this is an abstract representation in BPMN to demonstrate how most of these systems currently now work. So you have three parties: a requester, a smart contract, and a patient. And a requester is the same one who actually asks to obtain access from a healthcare record, which is being forwarded to the patient, which can actually grant or deny this access. But as you can see, the data itself, as most of the time, if this would be a hospital, the data would still be stored within the hospital itself. So although the permission may not have been given, a user, a super user or an admin user, or just a doctor could still actually perform a direct query on the databases of the hospital itself. Secondly, we also see that we have here a mapping of public keys stored within the smart contract in order to identify the patients. And here we can again identify the problem, okay, who maintains this mapping? And what do we do if one of our patients has lost or there was a theft of the private key? Because then it would be very easy for a malicious third party to just pretend like he or she is the patient. Now, in order to overcome these problems, in our article we propose an alternative design. One, to adopt IPFS for the decentralized storage of these electronic healthcare records. And two, to introduce a governing body for public key governance. Now, the first one, IPFS, it's a peer-to-peer distributed file system. So it actually uses the blockchain-based principles to share files and create blocks of them. So there will never be one file stored on one device. Actually, a file will be separated in smaller blocks and distributed over a whole network of the IPFS network. And if you then would like to view or have access to a certain file, you would have to demonstrate through your private key that you are the owner of this file. And then the network will provide this file again for you by locating all the different parts of this file and then presenting it to you. Now, in the case of an electronic healthcare system, a smart contract could serve as an access control system. So where the owner of a file through his or her private key could then grant access to a different private key to view or even modify the file if he or she wishes so. So what IPFS does, it actually provides an additional level of decentralization in the form of decentralized storage. So you have another level of security and decentralization in the system. So files are no longer stored on centralized servers. So we could now rely entirely on the public key cryptographic system to perform authentication of users. Now, this again brings us to the problem. If you completely or entirely rely on a public key cryptographic system for authentication, what are you going to do when these private keys go missing through loss or theft? And that is why we also opt to introduce a governing body for public key governance. So what we see as a governing body, this can be a national government of a country, for example, or any type of institution, maybe a more supervisory institution for medical data that can actually perform similar tasks. But this would be in our vision a centralized national or supervising institution. So what this governing body would do is it would store and verify the actual and the digital identities of its citizens. So you would have always, as a real person, have your national identification number. And on a digital level, this would be your private key. So in the case where you would lose your private key, what you could then do is you could notify the governing body and demonstrate through your real identity that you are actually or used to be the owner of this private key. And then it's up to you to generate a new private key and then demonstrate to the governing body, like, this was my old private key, I lost it or it was stolen. So then the governing body can also cancel any rights or actually witness or claim that this private key acknowledged that it has been stolen or lost, so that it no longer has any value for any systems, and that a new patient or a new citizen has come up with a new private key, which is by then the new digital identity of this patient. So in this case, you could actually overcome the problem of a loss or a theft of a private key of a patient or any citizen. If you would then see this in a new process environment, you would see that you have four parties. You have a requester, a patient, the blockchain or the smart contract itself, and then the governing body. And you can immediately see the difference compared to the previous process, that requester actually has no data stored. So now all the data of a patient is actually stored on the IPFS network, which is here represented with the patient. Because not that the patient itself will physically store the data, but the patient is the only one who can actually summon the full patient file on the IPFS. So for simplification reasons, we have here demonstrated that actually the patient sort of stores or actually owns completely the healthcare records by him or herself. And here the requester only requests, actually makes the events of requesting a patient file and then gets either informed if the patient granted or did not grant access to the file. Here also in our design, the mapping of the public keys is stored by the governing body. So it's only the public keys, not the private keys, that are being stored by the governing body. So it's always the patient that we assume will own his or her private key. The only thing that the governing body does is it creates a mapping between the identity of one of the patients or citizens to the public key, which is the digital identity of this patient in our case. So both the patient's primary public key and the requester's public key, the public address, will first have to be verified with the governing body to see that these are actual existing companies or patients, that these keys have not been corrupted or stolen. And if both are verified, only then will the smart contract proceed to asking permissions of the patients to ask them, this doctor or patient would like to have access to your file. Is this allowed or not? So this is a brief summary of our article. For future research, what we will do is we perform a more elaborate requirement analysis of what our blockchain-based electronic healthcare system, which requirements that will be needed. Then we would move to developing a working software prototype that also runs on the Ethereum blockchain. And third, work on a generalized design process for blockchain-based information systems, which we feel is would still provide a large benefit, a big benefit for the academic community. Thank you for listening, and I'm keen to hear your questions, which you can always send also to our email addresses.
Okay.
Hello, good afternoon, or at least afternoon.
Thank you. Thank you for presenting. And yes, as in with the first presentation, now again, first of all, I would like to call a discussant. And who will do a discussion?
Hi, so I'm going to discuss. So I basically see two-fold contribution of this approach. The one first is that now we are relieving the hospitals from the burden of retaining the data, and we are basically taking the data to the customer side. And the other is basically then how to manage the keys. So my first question would be like just a general question about the applicability of this approach. Like there are public and private keys, there are like it requires some tools on for the patient and things like that. And I can like even in this like I can see people around me who don't use even cell phones in this 21st century. So does it introduce more complexity to the ecosystem? Like there will be people who are not acquainted to technology, who don't know keys and things like that. Then we are putting burden on those people, like they have to use tools which they are not used to, they have to use technology and things like that. So isn't it making the eco a bit complex?
Okay, thank you for your question. I think you're completely right, because, well, as patients, we might care about the privacy of our data, but I can imagine that also a lot of people don't care at all. So indeed, we put a lot of burden on them. And actually, our solution does not solve that. And we do not even focus on that issue. But that's actually the same with all other previous solutions of using smart contracts and blockchain to deal with these privacy issues of electronic health records. Personally, I'm convinced that most of the people don't care at all. So that's an honest answer.
Yeah. So my second observation was like, if we look, for example, at Netherlands and Belgium and Germany, so there are people who like frequently commute between these countries for working or other purposes. So do you think this approach will work cross-border? Because like we have an authority, but then we need to make new contracts. Then there should be an authority in, let's suppose, in Belgium, which can communicate with authority in Netherlands for authentication and things like that. So like.
Yes, again, thank you. That's a very good issue, I think. We assume that this system can work within, let's say, the boundaries of one particular government. The government, like for instance in Belgium, the government is responsible anyway to match the real ID of people to their digital IDs. They are also responsible for registering who are authorized healthcare providers, so who can act as healthcare providers. So within a certain, let's say that the boundaries of a certain government, it can work. But if you want to work cross-national, well, you need to look at higher levels, like for instance, Europe. But you know, all these problems with Europe currently. So personally, I'm not very optimistic, but maybe we can start with introducing the system at a more local scale and then gradually expand.
Yeah. So in my opinion, one solution could be like you have a copy of your data, not encrypted or hashed. But then again, then you are prone to attacks, right? So if you are keeping your data unencrypted, then again you are prone to attacks.
Yeah.
Then as you said that there, in Belgium you have this authority, but if there are some states which do not have this authority, and then you introduce an authority with such mapping, then there is one more place for probable per attack, right? Then you have a place where there is sensitive data. So one more place which is a potential place for attack for the adversaries, right?
Yeah. Yeah, that's true. That's true. I think our solution very much relies on people, citizens, companies having trust in the government. So trust in government is very important there. But anyway, I think we have to trust government, because if a child is born, it's the government that actually provides identity to the child. So the parents can give a name to the child, but it's the government that gives identity to the child. So there is no other way. So, and I think that, I believe that trust in government is still higher than trust in any other institution which has commercial interests. And that's why we propose this, this governing body as, let's say, a third party that actually that verifies identity of who participates in the system, and that you can also rely on when, for instance, you lose your private key and you need to register another public key. But we know that this is a kind of compromise, and it's a bit against the philosophy of blockchain, or where blockchain initially started by, because the idea of blockchain is to remove all third parties, all middlemen, including governments. But well, we have this compromise.
Yeah. Another aspect I was thinking is like, so we have a societal responsibility as well. So as I discussed in my presentation, like we already have trust issues with data controllers, right? But at the same time, we have some societal responsibility as well. So if a business organization need my data, it's okay if I deny them my data. But if we look at the health sector, so it's a societal responsibility that we share our data with the organizations, and they do research on it, and they come up with new solutions, with new things. So but this is my opinion. Yeah. So now there are two situations. So my data was already in the hospital. I was just giving them the permission to use it. And now in your solution, I have the data. So now I have to give them the data and the permission, which is less probable, right? So if my data would reside in the hospital, it would be a bit easy to give them just the permission. But if the data and the permission both reside with me, it's less probable that I will give them my data, because then I fear more and I have more issues. So wouldn't it like slow down the research in health sector?
Yeah. I see the problem. I see the problem you mentioned. On the other hand, it's the same with all digital services that we use. You always give away some of your rights with the danger of that your privacy is compromised. But if you do not, you don't get the service. So it's a kind of trade-off, like what do you want to get from healthcare providers, and what risks are you willing to take regarding the privacy and protection of your data? So it's a kind of trade-off. And I don't think our solution will specifically help to solve that trade-off, but it does offer patients some level of assurance that their data is not accessed without they knowing it, which is the case with current solutions that use blockchains and smart contracts for managing electronic healthcare records. Because as our paper details, if a hospital stores your data, it can always access your data without you knowing it. And with our solution, that's no longer possible.
Yeah. So one possible solution could be pseudonymization, right? So what the hospital do, it basically removes the sensitive data. So the data is no more sensitive. It doesn't contain my personal information, but it contains the different steps of the guideline, right? And then the doctors or those people can access it, but they don't know who it belongs to. And if a doctor want to see my data, then I can use this system and allow him to like map the data with my sensitive data, and then he can access my records. But for the other doctors, like who don't need my identity, we do pseudonymization, and he can only access the activities, not the data.
Yeah, that's a good suggestion. Yes, I really like this but exactly because of that suggestion, the second part of our contribution, this governing body, is very important, because you need some instance, some institute to actually match the pseudonyms with the actual identity of the people. So I think you have to see our contribution not just as making sure that the data is not stored in the hospitals, but is stored in a distributed way and controlled by the patient, but also the second aspect of a governing body that actually is able to verify the real identity of people and match it to the public keys. I think both aspects are important, and just looking at one of the aspects is really not the solution that we propose. You have to look at both of them. Yeah.
True. I think I can leave the floor for other attendants, so they can ask questions.
Thank you for your questions. Thank you.
Okay, is there any questions from the audience? If you have any, please unmute yourself or write them in the chat window. Okay, then, yes.
I don't have a question exactly, or maybe it is a question also a bit. So there is this eIDAS regulation, which attempts to standardize and make interoperable electronic identities of different European countries. To some degree, it actually works too. If you are a Latvian or Finnish citizen living in Estonia, you can use your national ID card to access medical records in the Estonian system by going to the Estonian system, which then sends you for authentication to a gateway that your home country maintains. Like in case of Matulevich, it would presumably be Lithuania. And then this gateway does authorization and sends back to the Estonian medical system acknowledgement that yes, with the Latvian government or with the Lithuanian government, we are sure that this really is Raimundas, and then he can access his records in the patient portal. So these kinds of things, of course, it's still early days, and perhaps Raimundas can tell us about the practical experience more, how well it works in real life, but at least that's the theory.
That's a theory, actually, and it does not work because it requires also a lawful base and too many questions not answered yet.
Yeah, well, I was afraid that the technical solution is only a small part of the puzzle, and in practice you need a lot more. But just as a comment that there is already some work in this direction.
Yeah, I think that's a very good comment, actually. And from the perspective of a patient, I think that something can be arranged on a supranational level. But there is also the question of who is recognized as a healthcare provider. And there is European legislation, there is national legislation, and the rules in different countries are different, actually, like who is recognized as somebody that is legally allowed to provide healthcare to somebody. And also from that side, some solutions and some agreements on supranational levels are needed, like to roll out the solution on a broader scale. We recognize this. We don't have any concrete solution for that, so that's politics, I guess.
I also have a question about your, as you mentioned, second contribution regarding the government institution. So basically, what constraints you put on him? I mean, how you would convince him that he needs to manage these keys? Or, I mean, what is the cost of being involved in the, what is the lawful base? I mean, what are the requirements which you potentially put on him?
Okay, yeah, good question. I think the benefits for government are the welfare of the people and taking care of the good health of the people, because what we initially started from is how to share patient data across different healthcare, how to share patient data between healthcare providers. That's actually the initial problem. And actually only the security and the privacy of the data is a secondary problem, I would say. It is important, but the most important thing is how to make sure that doctors do not do the same things twice and enter the same data twice and have inconsistent information about the patient. And I think that's really in the interest of governments to make sure that the accurate data about the patient can be shared across with all people that have an interest in the health of the patient. And I think that's the way to motivate governments to actually participate in this kind of projects.
Mm-hmm. Okay. All right. Is there any other questions, comments, feedback? If not, then thank you very much.
Thank you.
Thank you very much. And then let's move to the third presentation of the session. And now we will hear about the verifiable multi-party business process automation presented, I believe, by Actor. And the work is done together with Yusuf Sim and Jamie Steiner. So Actor, floor is yours.
Yes, hello. Thank you for the introduction. Can you see my screen? Okay, good. So yes, I'm here to talk about multi-party business process automation. The paper is written jointly with Joseph Sim and Jamie Steiner. And we all work for Guardtime, and the underlying product, verifiable business process engine, this actually more people contributed into designing and developing this. So this is an what I'm going to describe, that at least part of it have already been implemented, sorry, and are being used in practice. So what is the motivation? The business process automation has been used to make running businesses more efficient, but so far those benefits have been limited to mostly to processes happening within the confines of one business entity, one company. And in order to expand or scale those benefits to also include processes running across business borders or across companies, what is needed is first a shared definition or understanding of the allowed transitions from one state to another in the business process, which we more or less already know how to do by describing the process either in a contract or in more formally using DPMN or things like that. So this shared understanding of what the process definition is can already be achieved. But shared understanding of the current state and history of any given business process is much more difficult, because normally those process management systems, they are still the process is managed within one system, and if this is owned or executed or maintained by one company, then sometimes this one company is reluctant to give access to their internal systems to the partners. And sometimes the partners may be also reluctant to trust that the party who is maintaining the system is maintaining it accurately and in their joint benefit. So this is a trust issue. And looking at maybe trying to resolve this trust issue by moving the management of the process state and the process history to an independent and external third party, then what this third party needs to provide to all the relying parties is to be able to prove the current state of the process so that everybody knows where they stand, to prove the history of state changes that led to the current state of the process so that everybody has a common understanding of what were the previous steps and how did we get in the current state. And in particular, this means that there is also need for this process management engine or process management platform to be able to prove that what they are showing to their parties in the process, that this is a complete history, that no steps are missing. For example, in a platform provider maintaining records of company stocks, then a potential attack would be that for the benefit of one shareholder, temporarily the number of shares that this shareholder has is increased, then some certificate or something is produced based on this falsified data, and then the information is changed back to what it legally should be. And then the question, if the reporting of the history of the process is not guaranteed to be complete, then it is possible to hide those intermediate steps from other parties, from other shareholders, and how to prevent this kind of flip-flop attacks. This is one of the questions. So this is why the complete history proof is needed, and also proof that this is the only history, so that the platform cannot show one version of the process history to one participant, another version of the process history to another one. So if a platform for running business processes or executing business processes can provide those proofs or those assurances, then this gives a much stronger reason for the participants relying on this platform to trust it. And historically, if you look at these requirements, then this really is very reminds you of what was the original motivation behind the blockchain and distributed ledger technology, to make this kind of history universally visible, universally verifiable, transaction history of money transfers in particular. If you look at the most famous example of Bitcoin. And now these platforms, they're also considering all of this. It should not come as a surprise that there are also proposals out which use blockchain and distributed ledger technology for executing other business processes in a transparent and verifiable way. But these approaches, blockchain and the distributed ledger-based approaches, that typically then implement the business process as a smart contract on top of this blockchain platform, where different parties post events to advance the business process to the next step. These suffer from scalability and privacy problems. For privacy problems, the original Bitcoin design included all the details of all transactions in the public ledger, and this of course is no good for privacy, and also in case of business confidentiality, this is an issue. So now we are seeing designs with so-called off-chain model, where only cryptographic commitments of the process state or the contract state are posted to the publicly visible ledger, but the actual details of the transactions and the states are kept off-chain. So the blockchain or public ledger acts as a trust anchor to verify the integrity of the underlying records, but the records themselves are kept in private. And on the other hand, also for performance reasons, with a lot of transactions and a lot of processes managed by a platform, then the computation overhead of verifying those gets quite high. And this is also something that we are witnessing already in the blockchain world, where we see the notion of so-called light clients and full clients, where some clients do not keep the whole ledger, a copy of the whole ledger, but instead ask a service provider to maintain the copy of the ledger for them, and then they go and consult the ledger by querying those records that they care about. And then the question is, how do those clients know that the ledger their service provider is using is correct, and the responses that the service provider is providing to them based on their queries, how do they know that they are correct, they correspond to the actual ledger. And also we are seeing in many blockchain designs this approach where not all of the nodes in the blockchain do the verification all the time, like it was in the initial Bitcoin design, but there are just a few designated verifiers called the validator nodes, which basically act like notaries for the rest of the nodes by checking that everything is in order and issuing their assurances or confirmations of it. And taking those developments into the next logical step, our approach is based actually on using an authenticated data structure, which by definition is a structure that can be managed by an untrusted service provider, and in such a way that every time when clients issue requests to update the data structure or issue queries to get information from this data structure, the service provider can respond with after performing the desired actions. They can also respond with proof that the action was carried out correctly, that the update was done as client requested, or that the response to the query was extracted from the data structure and corresponds to the data in the structure. And we are using this authenticated data structure to split the auditing of the process history in two levels. On first level, on the higher level or top level, there are global auditors who attest that the maintenance of the data structure has been carried out correctly by the service provider, which means that there is one single history of changes for each process, mainly. And then there are local auditors who, based on this assurance from the global auditors, can extract this one single history of a process from this global data structure, and then use the business rules to verify that those transactions that have been recorded in the data structure, that they actually correspond to the business process as agreed, so that the process has been executed properly. And the data structure that we are using is based on Merkle tree. So this is a tree like data structure where the actual input data is installed in the leaf nodes of a binary tree. And then going up in the tree, at every non-leaf node, the two child nodes are concatenated and the hash value is inserted in the parent node. And the result is that the hash value that ends up in the root of this tree indirectly represents all of the inputs. It is possible to extract a compact proof for any of those original inputs, linking it to the root node in such a way that it is cryptographically verifiable. And this means that if the root node is somehow authenticated, whether it is authorized by the notaries or published or something like that, it is possible to know that indirectly this authentication also applies to all of the individual inputs. And we use it, this Merkle tree, in such a configuration that for each process identifier, we fix a designated leaf in the tree. So based on the process identifier, it is possible to know which leaf must keep the current state of the process. And then all the updates to the process state must be posted into this leaf of the particular data structure. Anything posted elsewhere, by definition, is not applicable to this process. And the service provider then updates this tree structure in response to client queries, sending in notifications about process updates. And the service provider also keeps a history of changes to the tree. So old states of the process can be verified against old version of the tree, and new states can be verified against new versions of the tree. Now, for efficiency, the updates to the tree are applied in batches. So during a fixed length time period, the service provider collects a number of inputs from different clients, updating their different processes, aggregates the new states, and then posts a commitment of this new aggregate state. And after each batch, this posting of this new commitment of this new aggregate state, this can be verified by this global set of auditors to see that every time when the process state was updated, this was in response to a legitimate client request and nothing else was changed. So this is to guarantee the technical integrity of this data structure so that the internal invariants of this data structure are maintained. And the invariance that we want to maintain is that to be able to recover the process histories from this data structure, we keep a record with 3 fields for each process. And the first field, so instead of just the process state, we keep a little bit more information for efficiency and security. And so the first field of this three field record of a process state is a hash value of the state itself. So we could also, if we didn't care about confidentiality, we could post the process state itself in this record. But we, in our design, we keep the actual process state of the chain And in this publicly shared the data structure, we will post hashes of the process states. Then another field in this process record is the time of the last state changed. This basically indicates which version of the tree was when the last time this process was changed. And this allows for fast and efficient recovery of a complete process history, as based on those back pointers to the previous change, we can skip the intermediate states of the tree where this process did not change. So if a business process lays dormant for a long time, other processes may be evolving, maybe getting updates. So the tree evolves, new updates are posted in the tree, but an auditor wanting to verify the history of one given process, they can skip those intermediate states because they know there was nothing, no changes to the tree, to the state of the process in those updates to the tree. And then in order to be able to really be sure that those back pointers do not skip any intermediate states or any potentially malicious changes that the service provider might want to hide, the third field that is maintained is a counter of state changes. So the definition of this counter is that this has to be incremented by exactly 1 every time when the state of this particular process is updated. And this is the field that the global auditors use to verify that the history of updates is complete. So the idea here is that when the service provider sends an updated state of the tree for the global auditors to be verified, he shows all the changes to all the processes that have been made in this batch, and the auditors will be able to verify that each of those counters were incremented exactly by 1 in such a mechanism that the old state of the record, along with the version of the tree where it appears, this proof is sent to the auditor, and then the auditor can verify that the current state of the record or the old state of the record matches what they have on in their own internal state of the auditor. Then that update was done correctly by updating the process state, by linking to the previous state change, and by incrementing the counter by 1, and that the new state corresponds to the new root hash of the tree. And after doing this verification, the auditor can record the new state of the tree, new root hash of the tree as their internal state, and they do not actually need to keep, the auditor does not need to keep the whole tree. The service provider can always provide proof that the current state of the record matches the old state of the tree, and then that update is done correctly, and based on this information, auditor can verify and can adopt the new state of the tree as a current known good state. And so we have implemented this in a prototype platform, and we have this proposed this idea of verifiable business processes where the tracking of process history is based on authenticated data structures with 2-level auditing. So a set of global auditors can audit the service provider for correct operation of the data structure, and then local auditors can audit the history of a business process locally against this global data structure. We have implemented this solution. An older version is actually already in production use, and older versions that uses a slightly less efficient auditing mechanism to track that the service provider is actually maintaining the data structure correctly. And this older version was already in production use by a client. And this the value or the increment of this new proposal is this counter-based verification mechanism, which is more efficient than what we have implemented in the production now. And for the research part, we see future work is to extend this whole approach to more expressive process description languages. I didn't mention it before, but the current implementation is based on finite state machines as a process definition. And another limitation of the current work is that those definitions on the finite state machines, they use a proprietary notation or format for developed for this tool, and we would like to integrate it after expanding the expressiveness of the model. We would also like to integrate it into existing business process management tools, so that it would be possible to export process definitions from other tools into this engine for execution. And that's it for me. Thank you.
Thank you very much. And okay, first I'd like to call a discussant, Gert. Gert, floor is yours.
Okay, thank you. Okay, Ato, thank you very much. When I read the paper, I thought it was a very clear, well-structured, well-written paper. The problem you address is lack of trust in multi-party business processes. And of course, that can present limitations to the further automation of business processes. I certainly agree that current solutions based on blockchain and smart contracts are hard to scale. Your solution makes use of a transaction-based server, and essentially it commits process instance states to an authenticated data structure such that the correctness of these states can easily be verified. And technically it's based on cryptographic properties of Sparkle-Merkle trees, verifiable state machines, and a verifiable log of registry changes. I think the paper explains the solution very well and also is successful in comparing it to alternative blockchain smart contract-based solutions in terms of security, performance, and also specifically scalability. However, as you acknowledge in the paper, the obvious limitation is currently a lack of evaluation, given that your solution is not implemented yet in established BPM systems. Although you confuse me a little bit in the presentation because you talk about that it is implemented in some kind of production system. So yeah. My first question is, do you have any concrete plans in the direction of an integration into established BPM systems? For instance, do you have contacts with designers and vendors of such systems that would be interested in integrating your solution as let's say, an additional functionality?
So we don't have any specific agreements or contracts in place. We have some contacts, but no contracts yet. I'm not sure which one did you ask. But
I don't know.
Yeah.
My question is, do you have any? Is there any in the foreseeable future? Is this a direction you want to move into, or do you plan to develop an own system that integrates this functionality?
As far as I know, my company is not going to develop our own. Well, in a way, we have developed. The current implementation is a custom-made, sort of limited process execution engine, and the current production use is based on it. But we see that in the future, in long term, we don't want to be competing with workflow engines in this space. So the direction is, the plan is to integrate with established engines instead of trying to compete with them in the long term.
Okay, that's clear. Second question I had is, what is important in your solution is that there is trust in this transaction server, and to establish this trust, you heavily rely on what you call external auditors. But it's not very clear who are these external auditors and who then establishes trust in these auditors.
Yeah, well, that's a very good question. It's this age-old question of what do the turtles stand on, basically. So you could answer that so there is one largest turtle that smaller ones are standing on top of, or you could try to make the turtles all the way down, so you have another auditor auditing those auditors and issuing certificates of best practices and whatnot. So this is actually outside. This is more about business development and maybe sales and marketing question. It's outside of the technical part. We provide the means for the auditors to make statements, to issue the assurances or confirmations to users. But how exactly in each specific business case, who would be such a trusted party, and how to select them depending on the users, this is, I would say, for me as an engineer, this is out of scope.
Okay, that's an honest question, but I think it is important for practical implementation
Yes,
of your approach, because what if such external auditor enters into some kind of coalition with the company that owns the transaction-based server? So, it's kind of shifting the problem, I would say. So it's not a technical issue anyway, but it is a policy governance related issue with respect to your solution.
A way to reduce trust in one given auditor is what I probably didn't stress in the presentation, is that there can be multiple auditors, and users can say that they only accept an updated new state of the data structure if at least some forum of those auditors have approved it. And a benefit, if you put it like that, it starts to look more like a blockchain-based solution with consensus again. But the benefit of this authenticated data structure is that each auditor can do the verification independently. There is no need for the auditors to synchronize between themselves. And then the service provider can just collect those confirmation from the auditors in parallel. And then users can accept the new state of the tree when a sufficient number of those confirmations have been collected.
Okay. I think so too. Actually, I think it's clear in the paper that it was in the presentation that you actually rely on a set of auditors to do this independent verification work. I have a third question. That's my final question before I give the floor to the audience. And this relates to the process definitions. Because if some party wants to verify whether the process instance state is correct, you also need to refer to some process definition, because correctness is relative. It's dependent on the process definition itself. Now, if multiple parties involved in the process refer to different process definitions, because maybe one of the parties changed the process definition without the other parties knowing this, then the interpretation of a process instance state can be different amongst those participants. And then it would be hard to agree on what is the correct state. So do you also have a solution to prevent that one of the parties will change the process definition without the others knowing this? So what about maintaining like the one and only definition of a process?
Mm-hmm. Yeah, so the solution that we have in this VBP engine right now is that we don't, at the moment, we don't support updates to the definition of an already running process. And the way we handle committing to the process definition is that when a new process instance is created, then this creation record contains a hash value of the process definition. So this is also linked into this history. Everybody who has an authentic copy of the process definition can verify that this is indeed authentic. And if not, if somebody has tampered with their copy, they can learn of this fact, and then they can start looking for an authentic version. Again, since this is all in this off-chain model, if you lose your original record, or if you somehow spoil your original record, the data structure can tell you that your record is spoiled, but it does not allow you to recover the original version. Yeah. So you need to keep your records carefully, but at least if you have done so, you can verify it, and also you can prove to an external party that your records are authentic, that you haven't tampered or spoiled them.
Okay. Thank you very much. That's very clear, Atto. I think when you want to continue this research, you might have a look at research on what happens if process definitions definitions, sorry, change during process execution. There has been some research on that, on how to be.
Yeah, we also have been thinking
at,
about it, but it's not in the current implementation.
Thank you very much. Okay, any questions from the audience? It seems that everything is very clear. Everything is okay. Okay, then. In that case, thank you, Arto, very much.
Thank you.
All right, so now let me share again my screen and let's go to the closing part of the workshop and maybe to have some, also to have some discussion about the future of the workshop. Okay, so just a minute. So this is where I left you with the previous presentation. All right, so we left with the agenda. And okay, let's see what has happened today, just as a summary of all the talks. Okay, so basically the idea was to discuss the BPMN with respect to the security and privacy and to see how different techniques could be used to make to guarantee security and privacy. And actually, well, we did not have any contribution this year from the distributed process mining or artificial intelligence, but basically the other two fields were quite covered this year. And just to summarize that, okay, in total we had like 3 presentations, and with respect to this intersection between the privacy aware, privacy enhancing technologies and business processes, we had the discussion about the limitation of data with respect to the GDPR compliance. Also, the use of the security and privacy policies on how this actually can be done within when the process itself is being executed. On the another intersection on the smart contracts, blockchains, distributed ledgers, we had 2 talks and we had 2 interesting design solutions. One with the permission management and the involvement of the public key governance, and another talk including the authenticated data structures and how this can be done using the Merkle trees. So this is, I think, is the message of this year, that, okay, these processes are still important and there are the means, but also there is also a field for, you know, further on advances and further research there. And actually speaking about the next year, I have the question basically to all the audience. I would like also to hear some of your inputs. What would you expect as the part of the next year? So this is actually the current stage, but do you see any interesting topics which potentially needs to be included into the call for papers for the next editions of the SPBP? Or should the next edition of SPBP happen at all? That's also a question. So I would like to have some discussion and feedback on these aspects. Yes, if you have some ideas, please do unmute your mic and tell.
Raimundas, my point of view is first of all that despite we didn't have any proposal related to artificial intelligence this year, this topic should remain because there are more and more papers, researchers that try to connect artificial intelligence with security, with anything. So I think this is something that is promising, and I'm pretty sure that next year we should have some proposal related to this topic of artificial intelligence. For the other one, clearly still makes sense because privacy, blockchain still remains hot topics.
Thank you, Nicholas. Anyone else?
Yeah,
Yes,
Raimundas, Nicholas. Well, congratulations for having this workshop. I think it's very useful, a very good event also. I don't remember exactly the call for papers, but I think what is still quite hot nowadays is the concept of privacy by design and by default imposed by GDPR, and how can this be incorporated in the design of business processes? I don't remember. Maybe it's in the call for papers already this year, but that's certainly something to repeat for next year.
Thank you. Any other ideas?
We can see distributed process mining. So I think the word distributed somehow restricts the process mining contribution. So if we remove the distributed and keep it just process mining, maybe we attract more people like compliance checking for privacy and things like that.
Mm-hmm. All right. Any other thoughts? So these were basically the speakers and the contributors to the, the direct contributors. Anything from the audience? Okay, everyone is very, very shy to contribute to the workshop. Okay, in that case, I think that, well, yeah, right. I have still two questions. Actually, the first question comes to all of the presenters. We were able to see and share the presentations, the videos, and also the slides in the Hover platform. But I think after some time, this will disappear. Is it okay if I will share your videos in the workshop website? All right, I see.
Okay,
I see yeses. Actor?
Yes, okay for me too.
Okay, so thank you. And I will basically provide the recorded videos, which you also submitted for the workshop. Another piece of the information, it comes regarding the proceedings of the workshop. And as it is the tradition of the workshop, there will be the post proceedings of all the papers. So all the authors will be contacted again by the workshop chairs, already BPM workshop chairs, regarding the final instructions on how you need to submit your final camera ready copies. And basically you can still do some updates to your current papers if you see that, you know, the useful stuff from the discussions that you had today. Maybe you have some other ideas. So there is still okay to do the final camera ready copy for the post proceedings of the workshop edition. Okay, coming with that, I should say thank you for all the participants. Thank you for all the contributors. And I hope to see you all in the next edition of the SPBP.
Thank you, Raimondas, for all of your good work as well, leading this workshop. So thank you for all the work you did for this event to happen.
And thanks, Nicola, for sharing it.
Yeah. Thank you, Raimondas and Nicolas and all other colleagues. And let's hope that we can meet each other live next year.
Let's look for that.
Yes.
Okay.
Thank you.
Thank you.
I have a final question.
Yes.
Raimondas, Nicolas, do you have any rough estimate of what's the timeline for this post publishing would be?
Usually what was happening with the previous editions, it is like takes 2-3 months.
Ah, okay. Yeah, my main question was about when is updated camera ready copy due? How much time do we have still to work on it?
I will send a question to the workshop chairs and then I can inform you. But usually it takes like 2-3 months until you know it's finally published.
Ah, okay.
That was like previous years.
Mm-hmm. Thank you so much.
Okay, thanks a lot.
Thank you.
Stay healthy.
Thank you. Bye bye.
Enjoy also the conference.